Now let's first note that h of n minus 1 is equal to h of n1. You might think about that. Okay, h of n minus 1 is the way to get n minus 1 heads on n flips. H of n1 is the way to get 1 head on n flips. But of course then, h of n1 is also the number of ways to get 1 tail on n flips. And to get 1 tail, you're going to get n minus 1 heads, so h of n minus 1, it could also be the number of ways to get just 1 head. In any case, this number and this number are equal. If you just flip the rows of heads and tails, you see that. And since this number is n, this number is n. Okay. Now, we want to look at an application of this and the fact that h of n1 equals n, which is h of n minus 1 also, to the evaluating the difference quotient for a power function. Okay, the difference quotient for a power function, f of x plus h minus f of x over h, and we're going to do this only for a power function where f of x is x to the n, where n is a positive integer. Now we've used p in general for the power of x, but we can use any letter we want for the exponent. And in this case, we're going to use n to indicate or to kind of connote to ourselves that we're talking about a positive integer, a counting number. Okay, so what do we get? F of x plus h is then x plus h to the n. And f of x is nothing but just x to the n. We're going to divide that by h. So this difference quotient gives us this result. And I'd better be careful to make my h's clearly distinct from my n's. If I get a short stem on the h or a long stem on the n, you wouldn't be able to tell the difference. Okay, so how do we simplify this? Well, we know that x plus h to the n is equal to this. So that's what? H of n times x to the n plus h of n minus 1 times x to the n minus 1 times h. Didn't leave myself much room, so I'm going to have to kind of extend this numerator here. I'll put parentheses here so we can see what's going on. So we've got then h of n minus 2 times x to the n minus 2 times h squared, and I'm just repeating what I have here, n plus, and so on, down to the end, and I'm just going to leave the dots here. We know that this ends when we get down to h of n0, and we'll have then h to the n but no x's. And then it's all this divided by h. Okay, well, if we divide all this by h, now wait a minute, now of course then we have minus x to the n. I was getting worried I was going to have to divide h by that. Well, h of n is just 1. H of n minus 1 is just n. Don't have things aligned very well here. Then plus whatever h of n minus 2 might happen to be multiplied by h squared, and so on. And then from that we subtract x to the n divided by h. Okay, well, 1x to the n minus x to the n leaves us 0. So what we have then is just n x to the n minus 1h plus h of n minus 2 h squared plus a bunch of other stuff. all divided by h. Again, things are getting jumbled here. Let me kind of draw a line of demarcation. Okay, well, h goes into nx to the n minus 1 h. N x to the n minus 1 times. And then h goes into this thing, h times. So there's going to be h times this. Times capital H of n minus 2 plus everything else. But it's not exactly everything else, because all the everything else's are also going to have to be divided by h. However, the power of h and everything else, well, the powers of h are increasing, so you're going to have at least an h squared in everything here. So that when you divide this and every subsequent term by h, you'll be able to factor out an h. Now, some of the remaining terms will still have h's in them, but at least you're going to have an h here times whatever this is. As h approaches 0, this approaches nx to the n minus 1. So the result approaches x. Okay, I wrote it carelessly. This approaches n times x to the n minus 1 as h approaches 0. Now, why is that a big deal? Well, that's a big deal because this is the slope of the graph of f of x between the x point and the x plus h point. And as h approaches 0, this approaches the slope of the tangent line at x. So because of this picture, where we have x here, x plus h here, f of x here, and f of x plus h here, the slope of this is equal to this difference quotient. And as h approaches 0, that slope approaches the slope of the tangent line at the graph point where the x-coordinate is x, okay? The point of tangency is at x. So the tangent line, well, tangent line slope is nx to the n minus 1. If f of x equals x to the n. Now, if n is a integer bigger than 1, the slope, the curvature will actually be up, but that makes no difference to the argument. Okay? This allows us to get the formula that gives us the slope graph. Okay, that's worth thinking about a little bit.